Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give a quick idea on the linear transformation of the plane, and then we shall move on to the linear transformation of vector space. So here is a bit of definition. We have a transformation defined as T, which is going to transform from a vector space with two dimensions to another vector space also with two dimensions. And here is, you can think of it as a rule, and this is the input. So input here has two components, x and y, and this one here is the output, which can be obtained if you consider the value of cos theta, sine theta, and so on in this way. And this is the input x and y given right next to it. So you need to do a bit of multiplication of matrices, if you like to think it that way, okay? So when you do that, it is going to be a rotation of the plane about the origin counterclockwise through an angle theta, something that looks like this. So counterclockwise is in this direction, and it will be considered through an angle. So here is theta. Okay, and just for a quick example here, you are asked to find the standard matrix of the linear transformation for t if theta is 45 degrees. Next, if you are given this kind of input, you need to be able to determine what is the result of this when you consider the transformation t. So what's the output of this one, okay? So the standard matrix, well, this is actually the standard matrix. This is what you need to consider, okay? So therefore, the standard matrix is given by this formula, which is cos theta, sine theta, and so on. So here cos and cos is the same thing. We have sine and negative sine of theta. So theta is 45 degrees. And here is negative sine 45 degrees. And this is sine of 45 degrees. Well, in order to know what's the cause of it, well, if you want to apply the basic trigonometry which you have learned, it is something to do with this. So here, if we have angle of 90 degrees, of course this one has to be 45 degrees, and this one also must be 45 degrees, because the total of this must be 180. Let me just draw it properly. So something like this, 90, this is 40, this is 40 degrees, okay? And the angle is the same for that. So here is like the length of it is just 1 unit, this is 1 unit, and according to the Pythagoras theorem, we will know that the hypotenuse here will be set 2. Yeah, because we know that the length here is going to be 1 squared plus 1 squared. If you take the square root here, so this will be square root of 2, set 2, okay? And if you want to know what is cos of 45 degrees, cos is this one over this one. So it will be 1 over set 2. Sine of 45 degrees, well, we know that because 45 degrees is on the first quadrant, then all the values here is just going to be positive, right? So cos 45 degrees is positive 1 over set 2. Sine 45 degrees, sine 45 degrees is 1 over this guy, 1 over set 2 as well. So here is negative for negative sine 45 degrees. For this one here is going to be 1 over set 2. This one is also 1 over set 2. So this is the standard matrix of the linear transformation when theta is 45 degrees. Next, find the values of this when input is given as 2 and 2. So we have t, 2 and 2, and we know from this we can find the output of it if we consider this result here, the standard matrix, because here we have theta 45 degrees and we have already calculated that. We're just going to use the result. And right next to it is this vector here, 2 and 2. And we're just going to do a multiplication of these two matrices. Well, for the first one here, this one and this one, it will be 2 over sub 2 minus 2 over sub 2. So the answer is 0. For this one and this one, it will be 2 over sub 2 plus 2 over sub 2, which is 4 over sub 2. And this is the result for this guy here. Okay, so that's it. Okay, quite a straightforward and easy example of linear transformation of the plane. Now let's move on to the idea of linear transformation on vector space. So when you talk about the linear transformation of vector space, we have the same idea which you have already seen in the previous videos. So when you talk about linear transformation, it has to fulfill the two conditions given here. So the first one is when you have two vectors u and v in this vector space, and therefore the process here must be true in order for it to be a linear transformation. So basically it says here that if you consider adding these vectors together and give them as an input to this transformation function, the result here will be the same if you consider them separately. So you give this as an input, do the transformation, get the result, and then do this one separately, where v is the input, find what the result of it, and then add them up together. Also, the second condition says that if you have scalar c, so if you want to consider this process, well, you can multiply this scalar with the vector, give it as an input to this function, and get the result. The result is the same thing if you consider taking out scalar out of this process, and then do this process and multiply the results together. So it should be the same. And as an example here, well, here we have a linear transformation defined as t, and here we have the process of turning this matrix with size n by n to n by m. And here the process says that if you supply matrix A to this transformation function, the result is going to be A transpose. So here you are asked to show that this transformation defined here is indeed a linear transformation. Therefore, we can start with the first part, which is trying to prove, or we're trying to prove that when you have vector u plus vector v as an input to this transformation function, this is the same as doing it separately. Okay, we have input u given to this transformation function, and then input v, and you add them up together, it should be the same. So in order to prove this, okay, we can consider, so here is like matrix, so we can consider having two matrices. For example, we can say that let A and B belongs in this vector space. So let A and B belongs in this vector space, right? So therefore we can start off by considering the left hand side. So here is the left hand side. So from the left hand side, we have t, A and B together, so A plus B, and this is equal to what is the rule given when you have the input inside this transformation function? The result says if you have A, the result is A transpose. So if you have A plus B, the result is going to be A plus B transpose. And based on the property of matrix transpose and so on, we know that we can consider this as A transpose plus B transpose. So what is A transpose? A transpose, according to the rule here, is TA. And what is B transpose? Well, since A transpose is TA, that means B transpose must be TB. And we have managed to show that the left hand side here is equal to the right hand side here as what we need to show in the first condition. So here we have U plus V as the input. Here we have A plus B as the input. And on the right hand side, we consider them separately, which is what we have managed to show right here. Okay. All right, next is we are going to try to prove that proving that we have T, C, vector U must be the same thing as C and then this guy over here. So this is the next part that we are trying to prove, and therefore we're going to again we are going to do some definition here. So we're going to let A is in this vector space and just C is a scalar. So this is just sort of definition in order to get us started with the proving. Okay, so therefore from the left hand side, so we consider TCA. So this is left hand side. TCA is equal to, based on the rule given here, it must be equal to CA transpose. And we know that the constant scalar can be taken out from the process here, so we will have CA transpose. And what is A transpose? A transpose is just TA, so C, T, A. And so we have managed to show the similarity between what we have here with the conditions set in this part. So you can see that here we have T, the input is C with certain vector. So here we have input C with matrix A. So this is the left hand side. And after the simple process given here, we can show that C can be considered taken out from the process here. And here we have TA, so it looks similar to this one. So left hand side, and this is the right hand side. Yeah. Okay. I think I've reached the end of this video. Thank you so much for watching, and I'll see you in the next video. Okay.